Hello everyone. So in today's video we'll talk about the beta distribution. Um, as you know, the beta distribution is the family of continuous probability distributions which defined on the interval 0 and 1. And it has like two positive shape parameters, alpha and beta, for example, in this video. So we try here today to try to find the mean of the random variable x, so which is follow like beta distribution with alpha and beta. So we need to find expectation of x, and at the same time we'll also find the variance of x. So we start like with just brief introduction of beta distribution. Like if we have, suppose we have like the random variable x, which is follow beta distribution with alpha and beta, and notice that alpha and beta both greater than 0, positive parameters, positive shape parameters. And then the probability density function PDF of this distribution will be like as follows. So it's 1 over beta function of alpha and beta, x to the power alpha minus 1, 1 minus x to the power beta minus 1. And then the interval, the random variable x can take the values between 0 and 1. Where beta function of alpha and beta is just gamma of alpha, gamma of beta, then numerator, the denominator is just gamma of alpha plus beta. As you know, the mean of this random variable x is equal to alpha divided by alpha plus beta, and the variance of this random variable x will be alpha beta in the numerator, and the denominator is alpha plus beta squared, all squared, times alpha plus beta plus 1. We'll try to obtain these using the just expectation rules of the random variable x. So we start with the expectation of random variable x. Because it's continuous, then we have integral here, this one. So the integral between 0 and 1, and then x f of x dx. So we will just write the integral of the x here, this one for the random, so the value for the random variable x, so times x to the power alpha minus 1 times 1 minus x to the beta minus 1, just the probability density function of beta distribution, and then all divided by the beta function alpha and beta. So when we multiply these, they have the same base here. So one of them is just the power is 1, and the other one is just alpha minus 1. So that give me just x to the power alpha. Now if we want to find that, because if we want to do like the integral for the probability density function of the beta distribution with different parameters, so we just need to change a little bit in the to the power of the x. We just say x plus alpha minus 1 plus 1 minus 1, so that give me x to the power alpha. The reason why I'm doing that, because the integral of this one on the red line, so the integral of this one will give me, so that will give me the beta function of alpha plus 1 and then beta. And as we'll see now, so 1 divided by beta function of alpha beta times beta of alpha, beta function of alpha plus 1 and beta. And from the definition of the beta function of alpha beta, that equal gamma of alpha, gamma of beta, and then gamma of alpha plus beta. Now if we have beta function of alpha plus 1 beta, so that will be gamma of alpha plus 1, gamma of beta, and then gamma of alpha plus 1 plus beta plus 1. So we'll see this in here. So we just substitute all of these expressions of the beta functions. So we'll do some algebra here, and we simplify this. So will be alpha gamma of beta, and then alpha plus beta gamma of alpha plus beta times gamma of alpha plus beta divided by gamma of alpha gamma of beta. Now what we've done here, so gamma of alpha, let's say gamma of alpha plus 1, we can write this as alpha gamma of alpha, alpha gamma of alpha, and then gamma of alpha plus beta plus 1, that equal alpha plus beta, then gamma of alpha plus beta. So this one cancel out with this one, and this one with this one. So the gamma of alpha plus beta with gamma of alpha plus beta. So what we left over here, we just have alpha in the numerator and then alpha plus beta in the denominator, which is this one is in the blue is the expectation of random variable x. So this is the mean of the random variable x, which is follow beta distribution with alpha and beta. Now in order to find the variance of x, we need to find expectation of x squared. Why? Because the variance of x so the variance of x, which is equal e of x squared minus e of x all squared. So this one is known now. This is equal alpha plus beta divided by alpha plus beta. Now we need now to find out the expectation of x squared. So what we have done here is just find the expectation of x squared, which is the integral of x squared f of x dx. And again we will write this one, but this time is x squared times the probability function of beta function. And then also we can see this one and this one, they have the same base, but the power is different, so we just add them because they have the same base, and we just add the power, like 2 plus alpha minus 1, which is equal, which we can write it like in here, like x to the power alpha plus 2 minus 1. And this one here, the integral of this one, this part in here, is just the beta function of alpha plus 2 and then beta. Again, we can just put the we just put everything in simple form, like gamma of in here, like this one will be gamma of alpha plus 2 gamma of beta in the numerator divided by gamma of alpha plus beta plus 2, and then the other one, this one is for gamma or beta function of alpha and beta. Again, to simplify this more, so for example in here, what we've done in here, in this part here, we just said so gamma of alpha plus 2, that equal alpha plus 1, this is 1, and then gamma of alpha plus 1. And then This one also can write as alpha gamma of alpha. So gamma of alpha, right in here, gamma of alpha plus 2 is just equal to alpha plus 1 and then gamma alpha plus 1. And then in here exactly this one, so it's alpha plus 1 and then gamma of alpha. Sorry, gamma of alpha. Yeah, sorry, it's the gamma of alpha in here. So this one equal gamma of alpha. So it's alpha plus 1 gamma of alpha, this one here. And then gamma of beta will be, we'll put it as it is. And then gamma of alpha plus beta plus 2, we can write this one again. We can simplify this one is alpha plus 1 of alpha plus beta plus 1 times alpha plus beta and then gamma of alpha plus beta. And then the denominator will be in here. You just reverse the numerator will be denominator will be numerator because it's the division in here. So now we can simplify this more. So we have gamma of alpha here with gamma of alpha cancel out, gamma of beta, and then gamma of alpha plus beta, gamma of alpha plus beta. So we left off with alpha times, in the numerator, alpha times alpha plus 1 divided by alpha plus beta times alpha plus beta plus 1. Now this is the variance of x. So variance of x equal e of x squared minus e of x all squared. So this one is what we left over from the expectation of x squared. So this one is expectation of x squared. And this one here is just alpha divided by alpha plus beta all squared. So it's just alpha squared. This one would be here. So it's alpha squared divided by alpha plus beta squared. Now we just now we have like different denominator here. So this one is different from this one. So we need to make them common denominator. So we just take the alpha plus beta squared times alpha plus beta plus 1, put them in the denominator, and then do some algebra here in order to get this part here. So we have alpha plus, so we have alpha plus 1 and then alpha times alpha plus beta. So this one times this one, so it will be alpha squared. This one times this one will be alpha beta. And this one times this one will be alpha, and this one times this one will be beta. So this one is between the brackets, and the other one is so it's will be the same thing. So in here it's alpha squared times alpha plus beta plus 1. Now so we'll simplify this by cancel out all of these expressions here. So for example, alpha cube with minus alpha cube, and then alpha squared beta with minus alpha squared beta will be 0. And then we have alpha squared with minus alpha squared. So what we left over in the numerator, just alpha beta, and then denominator will be alpha plus beta all squared times alpha plus beta plus 1, as you see in this slide here. So this is the variance of random variable x, which is follow beta distribution with two parameters, alpha and beta. I hope you enjoyed this video, and then good luck to all of you, and I wish you all the best. Thank you very much for watching.